for discrete data, we know how to find median and quartiles. But how to find quartiles and median for a continuous data? Alright, so this is the method to find median and quartiles for continuous data. So we call it cumulative frequency. We need to construct the cumulative frequency graph, because from there we can find the median and all the quartiles. Okay, so again, what is the median? Median is the middle value, or we can say split the data into two halves. It is 50% of the way through the data. The first quartile, Q1, symbolized as Q1, is the score value 25% of the way through the data. Third quartile, Q3, is the score value 75% of the way through the data. And we can also call it the nth percentile. Nth percentile, Pn, is the score value of n% of the way through the data. If P25, okay, so it means first quartile. P50, it means median. And P75, it means the third quartile. Yeah, okay, so let's have a look at this data. The data shown gives the weight of 80 male basketball players. So it means there are 80 basketball players here. Construct a cumulative frequency distribution table. Present the data on a cumulative frequency graph, and use your graph to estimate the median. Then from there we can also find the number of men weighing less than 83, number of men weighing more than 92, and 85th percentile. Okay, so it looks challenging here. Okay, now we are going to construct a cumulative frequency distribution table. Alright, we add one more column here, cumulative frequency column. Alright, so we add this. Okay, now cumulative frequency for the first one is 1. And then the next will be 1 plus 2. It becomes 3. And then after that, 3 plus 8. So it's always at the frequency before. So 3 plus 8, we get 11. 11 plus 16, what is that? 27. 27 plus 21, 48. 48 plus 19, 67 plus 8, 75 plus 3, 78, 79, and 80. Yes, we do have 80 male basketball players here. Right? This is what the meaning of cumulative frequency distribution table. Yeah? Okay, now let's have a look at what the cumulative frequency value means here. If we have 3 here, it means the weight that from 65 to 75, there are 3 male basketball players with between this range. If we read here 79, 79 means the weight which is below than 110. So to be more specific, it is between 65 to 110. Yeah, and then 80 here is the total of the male basketball players in this question. Okay. Alright, so here 48 means there are 48 players who weigh less than 90 kilograms. So 90, 48 is a point on the cumulative frequency graph. Okay, so that will be the next part of this question. Okay, so this is a cumulative frequency graph of the basketballer's weight. Alright, so if you see here, the y-axis is the cumulative frequency and the x-axis is weight in kilogram. Okay, look at the table now. So the weight in kilogram will be the x-axis. Alright, we are going to take the upper bound for each class interval. Okay, that will be the x, and the cumulative frequency will be the y values. Alright, so it means that 70 and 1 will be a coordinate. If we write it in a coordinate wise, it will be 71, the first coordinate followed by 75, 3. Yeah, so that from 75 and 3, and then followed 80 and 11. Okay, all this will be the coordinate on the graph. Yeah, okay, and then another thing that we need to look at, the class interval is in 65 to 70, 70 to 75. Yeah, as we will plot at 70 here, so we decide to bring down the range here. Okay, so on the graph you see it is multiple of 10. Okay, usually we will use the easier multiple, either multiple of 10 or multiple of 5. So it's easier to plot on the graph because the graph, nature of the graph is multiple of 5. Yeah, and we can easily relate it with multiple of 10 or even with multiple of 4, but try to avoid 4. So this is the easier range. Yeah, okay, so it will be 60 to 70, 70 to 80, 90 to 100, 100 to 110, and 110 to 120. Okay, so and then when we plot all of the point based from our upper bound and the cumulative frequency, so I'm gonna write here, this is the upper bound. Alright, and the cumulative frequency graph will always look like this regardless of whatever data that we have, because if you think carefully, so the cumulative frequency value, which will be our y-axis here, is always adding up from the values before. Yeah, there's no way the value will fluctuate, will goes down or get lesser than the value before. Make sense?